you to just look at it for a second. And see if you've ever seen these before. And if you have, why don't you talk to your group and tell me what you think those things are or where you've maybe seen them. I'll change it.
Tyler, have you seen one of them before? My brother's ear doctor uses one. Huh? Yeah, it hits it on the metal and then goes like this and sticks it by your ear. Even when you ring, I know, I'm sitting 10 feet away and you can still hear that thing ringing.
Okay, I heard some conversations about what they were or what people were thinking they were for. Would anyone want to raise their hand and tell us what their group talked about? A couple of people? Okay, so while we're sharing just for a minute maybe, let's just really carefully listen to what people would like to say about what their group is talking about. Nina?
There's like different notes, like different sounds, like a C or a flat or a B. You know what I'm saying?
So when you tap these, you're saying you get different music notes? Okay. And you notice what are you guys noticing that's different about these? Size, right? One's shorter than the other. Okay. Would anyone like to add to what Nina was saying, or did you want to add more?
I was gonna say that it like rings and it could be softer or higher, like a softer pitch or a higher pitch.
Okay. Now, it seems like you have quite a bit of experience, or at least you know more than I expected to know about these. Have you used one of these before?
No, but I've seen them before.
Okay, you've seen them be used. Now, has anybody used these before? Okay. So I will say definitely they are tuning forks. There's two different ones shown in the picture. What's the secret to using these? You hit them against a hard object. Like, could you show me what you know? Okay.
I'm gonna try.
Okay. You notice he just barely hit that there, and it starts to ring for quite a while. That one's still ringing, I can tell. Okay, one of the ways that you can ring these pretty safely without damaging them is the sole of your shoe is rubber, but it's hard enough to hit it pretty firmly, and you can get it to ring, and you won't dent the forks or anything, but you could hit the ends on the table to get it ringing. Okay, now once you touch it, you stop its ringing. But what we're going to do is kind of do a little investigation about how these things work, and I'm going to have you write down a few things that you notice as you do some specific things that you might not normally do with tuning forks. Any background on why you use a tuning fork or why they're called tuning forks? What do we do with them? Yeah. Say it a little louder.
They help you tune instruments.
Helping you tune instruments. You ring this, and then what?
Then you listen for the sound and try to tune up whatever it's using.
Okay. Now, have you used this for that purpose? My grandfather, whenever I was a kid, he carried one of these because he tuned pianos, and he did the same thing. He would ring it, and he would use this to set middle C on the piano, and then he would set the rest of the keys based on that one being in tune. So, I'm going to hand out something for you guys to write some information on. I'm going to do a demonstration first to show you kind of what I want you to write down, but you're going to do 3 other things with the tuning forks as groups. Each group's going to have one of these. And then at some point, the 2 tables are going to trade, and you're going to trade tuning forks and get a different one. Okay? What I'll do is I can get a couple people in the back. I'll start here. Okay, you notice that I've got 4 squares here? Tuning fork, ping pong ball, on paper, and in water. Okay? I'm going to show you and tell you a little bit about what's going to happen with these. We're going to start in the ping pong ball section. And I'm going to do that part as a demonstration. Okay? Anybody have any guesses of what I'm going to do? Say it again? Put it against the ping pong ball. Have you ever seen that done?
Yeah.
Yeah. So if I were to ring this and put it up against the ping pong ball, what do you guys think is going to happen?
It's gonna go flying out, brother.
It's going to stop? What's going to stop? This?
Raining.
Okay. Possibility. I heard some other things, Sam. Okay, the ping pong ball may go all over the place. Why were you thinking that? Okay, because the vibrations make it move. Other ideas? How many people are just like uncertain and they want to see? Okay, so, can everyone see this back here?
Yep.
You've got it set up kind of as a pendulum.
Or drive.
Well, I'll show you and we'll do this first one together. So you just watch the first time, okay? So, let me see. I'm gonna ring it on the side of this table so I can get a better ring. Now, one of the things is if you come into it, you know, you're going to just be hitting it. But did you notice? I'll do it again.
Because of the vibration.
Yeah, it's pretty exciting the first time I saw it happen because I was surprised too. Now, what we're going to do in each section is we're just going to use this space to write down some things that we saw. You can use words and you can use the drawing. So here in the ping pong ball section, I thought, as an example of what I was hoping you might do, I'm going to just draw the ping pong ball, and then you can just draw a basic, I don't know, does that look like a fork, tuning fork?
Yeah.
Yeah.
How about this? This helps better. Tuning fork.
It looks like a wishbone.
And I'm going to put ringing. It was ringing, right? Okay. So how would I show what happened here with just a drawing?
Here.
Arrows. Which arrow? Where would I put it like? Are you saying something like this?
Yeah.
Oh, okay. Then go back and forth. Also, I don't know how many people. I know a couple people in here really like to draw, so you may have seen this in like cartoons or I don't know. That's how I always try to show things we're moving. And then you could say, what can we describe in words? What can we say it did? We touched
Move back direction.
the ringing fork. To the ball. It what?
Move opposite direction.
Moved opposite direction? Is everyone good with that? To the ball. It moved away. You could say bounced, or I mean, it's up to you. So this is kind of what I wanted you to do to start. You can put it in your own words. I'm guessing that half of you, at least in here, could do better wording than I could ever do up front here. So while people are working on that, finishing that up, I'm going to hand out tuning forks. And one person can go out to the water fountain and fill it up with water. Of course, be careful with your laptops, but you'll get some instructions up front that'll kind of guide you as to what to do for the other 3 squares, okay? So I'll have the directions up front for the other 3 squares of what to do. All right? So it's 6.
Whoa.
What are you guys, 3?
No.
2, 1.
Take your hand off one piece, Tyler. Just hold by the little moment.
Okay, so I want to alert you that I'm going to change this up here
You see?
on the screen. So if you want to take one last look, you can. Then I'm going to put up the instructions about what you need to do to get these other 3 experiences, okay?
Oh, you can see it vibrating.
So number 1 says what you need to do for the tuning fork section. Okay? Number 2, this is what you're doing for the in the water section. And number 3 is the on paper section. Oh, you know what? I gotta change something. I made a mistake here.
Coffee.
Yes.
Oh, that's what happens with the paper. Break the table.
So what Wesley was doing right then was number 3.
Oh, it does feel weird. Hey, Tyler, rest it up against your hair.
Did you like a time though? That's how it is.
Oh, you know what?
heard him.
Tyler just brought up a point. He said, what happens if you put it up against your glasses? Now, if it's the frame of your glasses, probably not much. But if it's the lenses, these can, what do you think could happen? It could shatter glass.
They can?
They can.
Yeah, actually, it works.
Wait, to bring it. No, put it on.
One person can go out and get water. Once you get water, make sure you do that one and then dump the water. That way nobody spills it and they're like, oh no, my laptop's too hot.
This makes a buzzing noise.
At the same time,
Just
I know, but
oh, my hands smell like metal. What does that sound like?
mom vibrating.
Looks like you guys have got to start with what you need to do. Okay. If you have questions for what I'm asking you to do, just look up front, okay? So that's as if you do it like this one.
I know it sucks the water, it makes vibration happen somewhere.
James, you got the transports.
Yeah, there's water. Hey!
Hit it and then put it up on the table. I'm gonna sit over there for I don't get all the laps out here. Want me to go some water sound? Oh, dear.
I know that was
Hold you put it in too far. It sprays water, dude. Thing's on.
Touch it.
Now, when you guys were reading this and were listening to it, did you notice anything that's unique? Did you try to turn the fork?
Yeah, we did.
What did you notice?
fades.
Phase, then it goes in. It goes in and out.
Where was it going in? Where was it going out?
Where it's
It would fade when it's on its side.
Yeah, there is water.
We're at number 5.
Hey!
I should probably get water, huh?
Like, do anyone from your group have questions on the Okay, if you need anything, look up and then you should be good. Okay.
That's cool, Miss Coffee.
Danielle, if you want to move around, you're welcome.
That's how you do it.
John, so what just happened there?
The drain fork's vibrating and making the water shaking and splattering it everywhere. It's pretty cool.
What is that surprising you?
Yeah. This is cool.
Marquez, did you get to see that? Was that the first time you put it in?
Yeah.
How hard did you?
Like that. Put it in. And then it stops after a while.
What do you think it is that stops it?
Friction in between the water and this port. Like, well, there's not enough air for it to maneuver, and so then it like stops moving. It stays still.
So, do you think it's the same as water? And air? They act the same? They act differently? Now, so after you guys have done the water thing, I'm going to hand you one napkin. You can wipe up anything that's happening, and then you can dump your water.
Paper. It looks like
Still in the middle of the top. Do it in the floor? Yeah, it's the floor.
Oh man, I was splashed. I need more than one napkin.
It looks like it's
I need another napkin. We need
However. What?
I need another napkin.
That's cool.
What do you think's doing that?
The vibrate.
What?
The vibrate.
Vibration?
Vibration.
Yeah.
And the force. I think it's the force that you put on.
No, Steven. You know what I was saying? What happens? What could happen with glass?
What? Break.
It could break. Do you think that could possibly happen to your hearing too?
Yeah.
Why do you think so, Roberto?
The vibration, the force of the vibration.
The force of vibration. Which part of his hearing do you think it would break?
The diamond thing. I feel splash. Oh, the splash.
Splashes? Yes,
Splash.
splash. I think splash, but yes.
I feel splash. Look at that. Yeah, that's fun. What's wrong? Pool water, ready?
So, when you look closely, what did you notice? Did you guys get a chance to listen to it and move it around?
Not really. Try it, Kevin. Do what? It sounds like a lifesaver.
Try this too. Try holding it in front of your ear, but then just rotate it. And does it make it different?
Hey, the sound comes off from the center.
Okay, try that again. Try hitting it, and then slowly rotate it by your ear and see what.
There's no sound on this end.
On which end?
Watch here.
Try it again.
Center.
Oh, yeah.
Where did you find that it was loudest?
Right in the center.
Here, do it yourself so you can feel which direction it's pointing. I want you to try this too, Marquez. It's kind of interesting. I think what you feel.
It's in the center.
What was it you were noticing?
It's in the center.
The sound was?
Yeah.
So if I were ringing this, where would it be making more noise? Here or like this? Okay, try it again. See what you think.
It's making more noise like this.
Josh, did you feel the same thing? Whenever
Right here.
was it like that? It was louder.
It's still going.
Turn it to the side. Now turn it flat.
No, like this, look. Danny.
It's in the middle.
Touch it.
It feels cool on your ear.
Oh my god.
Doing rotating. Have you rotated the fork by your ear at all?
I don't like
And see what you notice like that. Yeah.
See how it's fading when it's
It makes different noises.
It makes different noises.
Fading one.
fading and louder.
Where are you noticing it's louder?
Like when?
Yeah, when?
Like when I'm turning it.
But, like, is there a certain point where you're turning that you're noticing?
On the side that you hit
Yeah,
it.
the side.
That side? Have you tried that, Stephanie? No. Ring it and try that.
Can we get an extra napkin?
Right there.
I'm just gonna put this one.
That's different. Because, I mean, it's doing the same thing, right?
Because you hit it with this side, not that side. And when you hit it with that, you move it around so it fades away when it goes that way and closer.
Have you guys tried hitting it from right there? Both at the same
Yeah,
time?
but
It makes a less.
Is it different?
kind of.
Kind of. You guys, I want to make sure everybody here in the next couple minutes trades tuning forks with the group next to them. So group 3 would trade with 4. Group 5 would trade with 6. Have you guys traded forks yet?
Oh no.
And then you guys.
Hey, we got trade.
Yeah, Tyler. I can't remember if.
Can I get another towel?
Oh. I'll grab it in a second. When you guys were doing the listening, have you listened to it closely?
Yeah.
Yeah. Have you noticed anything whenever you're like listening to it, thinking about it? For instance, have you tried rotating it and then turning it? Have you noticed anything?
No.
Tyler, it's a really high pitched sound.
Okay. So let me.
It sounds like a humming too.
If I were to go like this, I want both of you to try this. If I do this and I just compare, see if you notice anything when you do that.
It's like a hollow sound
Okay.
when you turn it.
When you turn. So is that as loud or louder than the other way?
Louder.
Louder. Try it again. See what you think.
Yeah, to me it's louder.
To you, it's louder. Kajua, have Kajua try that same thing.
Oh, I want to try go on top. Go on top. Just go on top.
You sound like a siren.
Siren. Like, excuse me, like going up and down. Okay. Where did you find this the loudest? If you need to try to get that again. See where it sounds the highest or the loudest.
Like when you're turning
Okay, like which direction?
this way.
So, when this side's facing your ear, it's louder. Okay. Is that the same as yours, Alpha?
Different.
What do you think? You guys are just hearing different things?
It might be the same. It might be the way that our ears are different.
I'll give directions in just a second about the back. Okay. So, have each of you gotten to hold the fork close so you can like
I have a
rotate
headache.
it?
It's not happening.
Say what?
But I have a headache that is so not happening.
Okay. So, how about for the two people with maybe without headaches? Did you get to do this? Hey, Melissa, did you get to try this? No.
That was weird.
Yeah. What I want you guys to do is go ahead and have everybody dump the water now. One person from each group. Now, if somebody has a dry napkin, share your napkin because I. Okay. So you can even put some notes here. This one had a higher. Okay. Just put them in notes. Okay? If you have something you can't show in word or show with pictures, put words in there. Okay. You notice some difference in the sound. You don't know how to show the difference in the sound? You can put a little note. This one was
This one was
different
louder,
in
huh?
this way.
The small one? The small one was loud, right? And this one was quiet, so I was quiet. The small one.
Do you want a ruler? There's
Let me see. I'd like 3D.
So on this, what are you showing here?
It's more like
The movements?
yeah, the vibration thing.
Okay, you know what we could do? If you want to put an arrow and label it vibration, that way I won't have to guess what you're showing me.
Alright.
Okay.
This one was like stronger when I went into the water.
This one vibrated more though.
Did it?
Yeah.
I saw this one. Like this one.
So you're saying this one vibrated more,
Like not like more, but
like faster?
yeah, like faster.
Faster.
Okay. When did you notice that it was vibrating faster? What told you that?
Like when I put it to the paper, the noise that it made, like it was faster than when we did this.
Okay, so the shorter one was faster.
This one was slower, but then stronger.
So you can put those notes, and you can also, if you can think of some way you might show that, you can add it in your drawing too. Okay. You should add also what you said about the water. Which one splashed the water more?
This one here, yeah.
This one? Why do you think it splashed the water more? Any ideas?
Because it's like, I think it just vibrates harder, like more.
Harder?
'Cause it has longer bars.
Okay.
Probably, I don't know. Probably it just vibrates harder.
Harder. And you're saying you think because it's longer?
Yeah, because it's water. Yeah.
Okay. So, just while you're drawing, what were you guys noticing as the differences between your forks, just in general? Like when you traded groups, did you notice anything different between that fork and this one?
Sound.
The sound? How was it sound different? Is it like louder or different sound? Or?
So it was just like it was like just loud. It was just louder.
Okay, which one? This one?
Theirs.
This one?
Theirs
This one?
was loud. Theirs was, it was like really loud. Ours was loud.
Okay, you can write that, Samira, a little note that said this one was louder. Okay. And also, I'm wondering when you said it was louder, was there anything different in the sound, or was it just like how loud they were was the main difference?
It was like how loud they were.
Like one would sound higher than the other, or just like
You
one
are
sound.
confusing me.
I guess if I say loud, I think about loud as like a stereo volume. Like if I want to make something loud, I just turn up the volume. It still sounds like guitar, but it's just loud guitar.
Yeah, it was just louder.
So you got the numbers written in there? Do you know much about the numbers? No. Samara? You know anything about the numbers on there? Does that work? To hand out what we're going to do.
It's like vibrating.
You're gonna love it. It's actually really interesting.
Oh.
One part's about waves, one part's about hearing in your ears, and one part's about sound in general. And each person has a different reading.
It's the last 5 minutes.
Yep. Try to get everybody's attention. Raise your hand when you're looking up front. Can everyone hear me? If you can, raise your hand. Okay. Now, if you noticed on the agenda, I have down written at the bottom, homework. Now, what I'm going to do, this is a really good homework assignment. It actually, each person in each group gets a different.
Exactly like that, yeah.
Okay, and you're saying the word vibrations.
Yeah.
And then I saw the ball moving up, so if I were drawing this, I would try to do something like this. Okay. And I'm going to put tuning fork vibrating. And I think maybe what I'm going to do too is I'm going to put when the tuning fork touched the ball. What could we finish this with? When the tuning fork touched the ball,
It moved.
it moved. The ball
Besides
moved.
too basic.
The ball what?
The ball
Bounce around.
started to gain momentum and
Oh, well, we can make it where we include some of our ideas about motion. Bounce. I'm going to just put bounced away, just for time's sake for me. Now, you'll do the same thing, pictures and some words to describe what you're observing in the other ones. I'll leave this up for just a second and then I'll put the instructions back up, okay? I'll give Dixie cups out in a minute and the person can go out and get water. So you can check out how this interacts whenever you touch it to water. 8. 7. 6. And 5.
Can we try it out? Or can
Yeah, you guys can try it out. Has everyone seen this up at the front for long enough to get an idea? Because what I'm going to do is put the directions up for what you do with this here in a second. Just be careful you don't touch this actual glass or something like your teeth. Well, why do you think it wouldn't be good to touch your teeth or glass? It could vibrate and crack glass or teeth. Like, I just saw some people getting them close to their faces. So, you know. Boy, don't touch them.
it's gonna be like oh, it feels weird. It's gonna be like right up break glass.
Where you go from?
Yeah, that's why it makes it, like when you touch it, it stops it, because on this side you're stopping the vibration, so it kind of transfers all the way over there and it stops. I just didn't want to say anything. Okay.
Wait,
Do you get it? Or no? You know what I'm saying? See, when you hit it, you transfer it here, and when you stop it,
oh,
even if you stop it this way, it goes either way.
So that's the part where number 3 describes what he's doing.
so are we doing the,
Try to stop it from the middle.
what, like,
Yeah. It feels weird
Yeah, I know.
because you feel both
like, yeah,
vibrations.
yeah.
You feel both vibrations in it. So the vibration, I think it happens in here and here outside in the middle part. That's why when he touched the ball, it just it transferred to it,
That's cool.
kind of like energy. Okay.
So are we gonna do this first? And then,
Like describe it, like what I just said.
yeah.
Like okay.
So you just draw it, right?
Yeah. Do the simple one. It's easier. So when it hits against like a steady object, like, because this will work. Not that much, but if it hits. That's why it holds on for a long time, because it's inside. So just draw like the vibrations. Vibration.
Or don't we gotta draw like how it's when it hits the table? Like, you know how we kind of did for the ping pong ball? Like,
Well, we don't
how
have
it
to.
doesn't move?
Well, it doesn't move anything. It's just vibration, unless you put it something that can move, like the ping ball. But that's why when you touch it, you don't move. You just feel it. Okay. So I think like inside. I think there's more vibrations inside because it's in both.
It's awesome.
Inside. Okay. So if you hit it against an odd, well, maybe the reason it moves is because it's hanging.
Yeah.
There's nothing pulling it down, just holding it. Okay,
So,
so
oh yeah, wait.
You guys do the water?
No,
No.
not yet.
Are you gonna dip it in or?
yeah, I guess it's gonna make waves. Watch.
It's gonna splash everywhere.
No, it's not. Is it? No. Okay, so how are you gonna describe it?
I'll put, oh wait, hold on. That would go here, right? So I just draw an arrow right there, because I put more vibration inside the two balls than before.
Yeah, because they're kind of intertwined. And then we can explain the reason why it holds on so long. Because it's so long and thin. The metal's thicker. It's got a hole in it. And then the inside, you can see it's kind of scratched. You see that? Like little cubes.
Oh yeah.
Maybe that's why it's
Like
so
before I couldn't see it.
Like if you see the light.
Let's see, second direction.
You can't feel it,
I know.
sort of, but
I thought
it's
you
there.
would.
And then up here it's all. Doesn't matter.
Bent up because of the table.
Yeah, and then the inside. Look at down here, it's all just lines. That's why I mean, it's just like squiggly. That's why you hear it so loud, it's squeaky.
So it goes up?
It's like you're moving these two, like combining them to make a sound inside.
Oh.
Like you hit it light, you hit it hard, like not louder. But have you seen? You hit it more to the edge, it gets louder.
Yeah.
It still vibrates. Really? Watch.
Okay.
Oh yeah, but you just can't hear it as much.
Yeah, so I guess like the closer it is to like air, like that, the louder it can get. So if you hit it here, more sound. If you hit it, what is it like?
Okay, there's a start, okay?
Like what would this be? Like the
Now
top?
you show what's happening.
The top and the bottom?
I think so. That's what I'm saying.
Yeah.
Sit closer to the top.
If you want to extend this, you can draw those out longer so they go
Sound
into
is
the water. I thought I heard you tell him here.
Oh, I think it's the nose.
Closer
Okay.
to the bottom.
Yeah.
It's not low, but it's deeper.
Oh, could it be the?
The sound is deeper. No, it's deeper. It's more.
Just deeper?
Yeah, it's deeper. The sound gets deep. The sound gets deeper. Okay, what else were we gonna say? Oh, and the vibrations go inside, and they only transfer on the outside because of it's in here. Like
Hold on, say that again. The vibration.
vibrations harder on the
Right on the
inside. Like the most of the vibrations on the inside, but like the only reason it's out here too is because of the effect. Like cause and effect. The effect is out here, and the cause is hitting it.
So.
You get it? Did I just confuse you?
Yeah. How do you put that in describing it?
Well, you can say that the most vibration is inside. That's where the sound is made. You can say that because the sound isn't made out here; it's in here. So you can say more vibration in the inside of the tuning fork. And that's what it's, well, you can, how are we gonna say that? The sound is created inside the tuning fork.
Oh, okay.
When did you notice it was loudest?
The sound is created inside
It does sound like a song.
If you hit it from this side,
of the tuning fork.
because you hit it from this side.
So what else were you gonna say? That's it, right?
Yeah.
Okay.
Do you want to do the water
Sure.
ones now?
Okay, you guys, what I want to have everybody do now and start thinking about, has anyone traded forks with the group next to them?
Wait, I didn't see that.
Okay, I would like you to trade here in a minute, just to see if you notice anything different.
Did you hear that?
Yeah.
about the forks
Sounded like a bug.
I know it.
Alright, here you go. Ready?
So it didn't make any thing.
Here, Cuervo. And just do it to the surface of the Cuervo. Pull up that chest.
Wait,
Sit down on the chair now.
it's not gonna work.
It works easier.
Huh.
It still does the noise. It goes
Yeah.
Makes
There it is.
like when you're splashing in the water.
Oh, okay. So you're saying the noise is like splashing in the water?
Yeah, so I guess they're both effects, they collided. It's exploded.
Now I notice you got more sound right here.
Yeah,
Is that compared to
down here.
down there? Oh, okay. So out on the ends, you're saying?
And the ends it's higher pitch, and then the bottom is
Oh, so you're saying? Why do you think that is?
because it's closer to your hand probably or something. And this one's probably out more. It has more room to create sound.
Some more room. What? When you said something near your hand, what do you think is happening between that and your hand?
Like you're getting force on it, so like that. You see how close it is, and then you hit it here. There's probably more, like less. I don't know how really to say it.
Do you feel it in this hand at all? Like, kind of. Yeah, like it stops it down here.
It's like when you're grabbing
Hands.
something.
Oh, like if I were to.
Like if you're grabbing it, when you're grabbing it here, it's kind of spreading. When you're grabbing it here, this is more loose end. It has more room. And right here, you're holding it tighter. If you hold it this way, it's probably this is. Oh, it's kind of work.
So you're thinking when it's, is it more room to
vibrate.
Okay, alright. So, when you guys did this, did you get a chance to get it and then try comparing here to here? Try turning it. If you haven't done that, try that. Try striking it and then rotate it there.
It's louder here.
Louder there. Try that out, Alex, and see if you notice the same thing. Why are you thinking that?
Right, it's louder when it's like
So
that.
you're noticing the same thing. Any ideas why it might be different?
Because the vibrations are going out.
Show me where.
Like I think the vibrations are going out this way and that way.
Okay.
And when it's like this, you're hearing it go up. When it's like this, you're hearing it come this way.
Okay. Careful with how hard you're hitting those guys.
Okay, so the water is like splashing in.
So maybe you should try drawing something in there about what you're hearing there and different, but just to make a record of it, what you're telling me about more weight, more sound.
More waves go this way.
Okay.
Because there's two.
Not a good idea.
Okay, if I can get everybody's attention real quick. 5,
We did that.
3. Okay, now what I want you to do is just put everything down for just a second. I want to take a step back. I know there's people that are still finishing putting the details here, okay? I know you're finishing writing your observations, but I want to show you, in the next couple minutes, I want you to go to the back. Now, if you look at the back right now, notice I've got tuning fork number 1. Now, it says modeling a tuning fork. We're making a model of how the tuning fork is doing what it's doing. You know, whenever you ring the fork, like what's actually going on there. Okay? I'd be really interested in seeing how you could show either, like I've heard people say vibrations and sound coming out of here. How could you show that? And what you're going to have to do is tuning fork 1 is already drawn for you, and tuning fork 2 was the second one you tried. So if your first one was shorter than the second one, draw tuning fork number 2 longer. Also, you might also be able to put, did anybody notice that there were some numbers or lettering here?
Yeah.
Yeah. If you know what the number was on port number 1, you could put that there. And then you could also show that on number 2. But I'm really interested in seeing how you think that the vibration and sound is coming away from the fork, okay? So, what I'd like to do is, for this part, maybe in the next 5 to 7 minutes, getting this part along with the front finished up. And I'll hand out a couple paper towels, and if you're done with the water, and you need to move on to this, why don't you have one person maybe go out now and dump it, and I'll hand out a paper towel. You can recycle the cups, okay?
And we got the aerial view.
The water splashes because of the vibrations interacting. The water splashes because of the vibrations interacting. What else? What else? Is that it mostly? That's why I made the sound. Oh wait, it can make the sound because the water went back down because of gravity. I don't know. I'm just gonna put that. The sound was great. So this kind of provided the pushing, I guess you can say, and water provided the sound. That's what I'm gonna say. The splash sound was caused because
of the vibration pushing it.
Because the vibration like kind of
Pushing
hit it up,
Oh, okay.
but they went down. So in a way, they work together. It's like when you're hitting it, you're pushing it down, and like.
That's on the paper.
Yeah. Wait, how are we gonna do the paper one?
Probably our own paper.
You're hitting wood. Okay. The splash occurred because. The pressure down.
Well, neither you guys are gonna win, so it really don't matter.
Pencil. Okay, so we gotta do
Paper.
You want me to hold up my paper and you do it or what?
You wanna hit it? Because I've been hitting it most of the time.
No, it's okay. It don't matter.
Okay, what I'm going to do right now, you guys, is I'm going to come around and I'm going to collect the tuning forks and have it sitting out in the front.
Oh, we need to hurry up and do this.
Okay.
That could seriously touch you guys. You need to trace it.
Sounds like a bug's dying.
Okay, I don't know how to explain that one.
Maybe because the I don't. Like I'm trying to feel if it like moves the paper.
Maybe the still one, and then it's, you know, when you go like, but this time you hit it with that. So it's the same thing, like. It's kind of the same thing, but a harder object. Because this one sounds weird. It's like, it's all creepy. I think it's creepy.
Careful there.
It doesn't, the paper doesn't move, it just kind of like collides.
Does it just make the sound?
Yeah, it just like collides. Maybe that little section moves, but I didn't. Did you feel it move, the paper? I don't know. I wasn't holding it.
Well, yeah. Kind of.
It didn't work. Yeah, it does move.
Like kind of feels when like not as much.
It just feels a little vibration.
Like it just shakes it. Shakes
Like
the paper.
my feeling and like, because I didn't know this moved. You hold the paper.
But you knew you're handmade.
Yeah, because you like holding it, you can kind of feel the vibrations coming out this way too.
Yeah. I noticed that there wasn't as much sound when you touch into your finger as the paper.
Because they're both massive, and this one has probably the mass has to do with it.
You guys, I am going to be passing out something to each table. I'm going to give it to you. You don't need to do anything. Just continue writing on this side of what you're thinking is going on with the sound and the vibrations, okay? But I